Previously, we talked about the different integer types in C, and we take a look at how signed and unsigned integer are being represented in our computer's memory. We also saw some brief description of the char type, where we explain what a character set is, a coded character set, and also the various character coding. So before we look into real floating point types, I want us to take a look at some other integer types and understand what is an integer overflow. So as you can see on my screen, I have printed the various size in bytes and also the number of bits making up a byte. As you can see, we have a char, right? A char is made up of 1 byte. That is, it has 8 bits on this system. This is not a general rule, okay? So you should never assume that on all computer systems the number of bits making up a byte is 8. No. Okay, one thing again we talked the last time is the system that enforces certain rules about this basic type, that is the character, okay, is always less than or equals to a short. As in the case of this one, the long and the long int, when we see here, the size is actually the same, okay, because we notice that the number of byte of a long is 8 and the number of byte of a long is also 8. So a long should never be greater, okay, than a long. It is always less than or equals to a long, okay. In our previous video, we also talk about a signed and an unsigned. So all of these integer, right, can be represented as a signed and an unsigned. Okay, now what this simply means is that when using a signed integer type, okay, that means the most significant bit, okay, is used to represent the sign. So as an example, let us look at the short. On the screen, we see that a short is made up of 2 bytes, so that is 16 bits. Simply means that the minimum value, or the range of value which can be stored in a signed short is actually -2 raised to the power 15 right up to 2 raised to the power 16 minus 1. So this is the range of value which can be stored in a signed integer type, okay. The general case is the number of value, okay, stored in a signed integer is actually 2 to the n minus 1. Here is a -2, okay, right up to 2 to the n minus 1 minus 1, okay. So the reason why there is a -1 here is simply because the one most significant bit is used to store the sign, okay. So that is why we have a -1, and the reason why we don't put a -1 here is simply because we are assuming to use the 2's complement, which is being used in most modern computer system, okay. If you don't understand what a 2's complement is, you should check on my previous video, okay. One thing I also forget to mention is if you declare a value, for example, if you declare a value without adding a sign or an unsigned keyword, right, most compilers usually add an extra keyword of sign in front of it. So for example, if you put a value of char, right, equals to 255, right, and put ch value of char equals to 265, and then let us try to this value and see what is it. The value 255 is printed correctly. Why? Simply because you can enforce the compiler that you should enforce it to be an unsigned. So in this case, let us remove this extra compiler parameter and see what this will be. Okay, you have seen here that the value is -1, okay. So this simply means if you declare a variable, okay, without the sign or the unsigned keyword, okay, the compiler actually places a signed keyword, okay. For example, this is simply like if we put a signed keyword, it's going to be the same thing, okay. So now let us put back our compiler flag saying we want an unsigned character, okay. So we have to remove this. For an unsigned integer type, it starts from 0 right up to 2 to the n minus 1, okay. So this rule is applicable to all the other basic integer types such as the char, the short, the int, okay, and so forth. So if you understand this rule, then you can just use the same rule to apply it to the other integer type. Let us move forward to understand how these various types have been formatted using the printf function. For example, if you want to print an unsigned integer, okay, you use the specifier %u, okay. If you want to print a value, okay, which is of a type a long integer, a %li or a %ld, okay, an unsigned long int, you can use a %lu, okay. This u here means unsigned. If it is also for a long int, you put lli, okay. If it's for an unsigned long int, you are going to put llu. Let us talk about the boolean type. The C99 standard introduced a new type called the bool, which simply means a boolean, that is, it holds only 2 values, that is 0, 1. So no matter what the value you put in, okay, if it is not a 0, it's going to be a 1. This is actually an integer type, okay, because if you can go to your compiler and you can print the size of a bool, the size of a bool is actually equal to the size of a character. Now if you declare your variable like this, underscore bool, right, and ch, and we put in any value, is going to be equals to 1. So if we add this, the value will still be equals to 1. Okay, so one thing I want to finalize with a bool integer type is under the header std bool, right, we have a macro that actually defines the bool type. Okay, so in this case, instead of us to use underscore bool, right, we could simply use bool like this. Okay, yeah, simply because under this header, right, there is a macro that actually extend. So let us talk a little bit about limit. This is a code I've been working, right? It doesn't matter. So let's just look at the limit header type, right? So if we right click and we go to the definition or the document of this limit header type, the limit header type defines the boundary between the maximum and the minimum integer type. So for example, you can see here char bit actually defines the number of bits, right? You can see s char, that is a signed character minimum. You can see the minimum value of a signed character is a negative 128. Okay, so we can also see an s char maximum. Okay, so this header file is very easy to understand, and I'll encourage you to open this header file and take a look of it at yourself, because here we have a lot of macro, okay, defining some of the minimum and the maximum values of an integer type. And one thing you also have to know is this is the compiler doesn't enforce this. Okay, so this is something known as an implementation behavior, in which the C standards give options to the compiler to to implement it. Okay, this is not enforced, okay, on all system. Yeah, that is what I'm trying to say. Is all system, this is not like something universal in such a way that if you go to in another system and you open this header file, you are going to see the number of bits, okay, making up a byte, it will be equal to 8. No, this is known as an implementation behavior, in which the C standard, okay, gives options, okay, specify how this will be. What is an overflow? Now, one thing I want to talk about overflow is there is nothing like an overflow on an unsigned integer type. That simply means no matter the value you give to an unsigned integer type, okay, the value will always be defined. On our screen, we have assigned the maximum value which can be stored in an unsigned char. Okay, let us add a +1 into this value and see what the result would be. I'm expecting 256, right, because the maximum value is 255, and if you add a 1, right, it should be 256. But what happened is our compiler actually print 0. Okay, let me explain to you what really happened. Char was equals to the maximum value, right, plus 1. Now the result will be equals to char, which is the value, right, mod the maximum. In this case of a char, the maximum of a char will be max plus 1, right? In this case, what is a mod? A mod simply means the remainder. Okay, when you divide this by this, okay, it's going to be the remainder. Yeah, ch is actually the unsigned char max, right? Mod unsigned char max again. So that is why unsigned char max again plus 1, which is going to give us a 0. Okay, the result of an unsigned integer type would always be defined. Okay, so now what is actually an overflow? An overflow, usually it always occur with a signed integer, right? For example, if you put in a char, right, and you set in a value bigger than the max of a signed char, right? Okay, let us see an example of this. So as you can see, I have set a signed char with the value 256, and we can see here that the compiler is giving us a warning and telling us we have an overflow. Okay, actually, if we try to overcome this overflow by typecasting this value into a sign, char, and see what will happen. Right now we have removed the warning that the compiler was telling us, but still, right, still the value we have is undefined. Okay, this value is undefined, and this is still an overflow. So you should never do this in your code. Okay, don't try to assign the value maximum than the specified maximum value required for a signed integer type. Now in this case, we have tried to convince the compiler, okay, by typecasting this value into a signed character, but still the value is maximum. Okay, it is bigger than the limit, than the maximum value required for a signed character. An overflow is an undefined behavior. That means you don't know what the outcome will be. So the compiler might choose to generate warning, give you errors, okay, or it might just ignore. Like in this case here, the compiler just simply ignore it. Yeah, we don't see any warning, we don't see any error, but Actually, our code is very wrong. That is it for just this short video which I just wanted to post, and in our next video we are going to talk about the real floating types. Okay, so that is it for the integer type. I hope the whole integer thing really gives you a wide understanding of the various C integers types. So I just want to thank you for viewing, and I will see you next time.